Who goes out to sea is interested, first of all, in the marine weather conditions. Therefore, he will want to know about the wind force and the sea state. You may be aware that the weather bulletins show the wind force according to the Beaufort scale, ranging from 0 to 12, while the sea state is indicated by the Douglas scale, ranging from 0 to 9. Therefore, the sea state is not always in the same scale range of the wind force, especially if we are close to the coast. It's clear that if the wind flows from the mainland, the sea state worsens considerably, despite the strength of the wind. This is already a first step in the reasoning to be done. A different issue is, however, talking about weather phenomena. To this purpose, we need to separate the marine weather conditions from the weather phenomena. The thunderstorms are the most relevant meteorological phenomena, even for sailing in the Mediterranean. They develop suddenly and are heavy, often accompanied by strong gusts of wind, lightning and thunders, and this can put a small boat into serious difficulty. However, a broad distinction needs to be done. There is a type of thunderstorm we can absurdly define as fair weather ones. They develop along the coast in the afternoon, when the temperature is particularly high. In this case, we deal with almost still seasonal thunderstorms developing in the afternoon, coming with gusts of wind, but localized and not moving in a rush. You can have frontal thunderstorms which instead form over the sea or along the coast because they are driven by a mass of cold air expanding, for instance, over a warm sea. In the latter example, the thunderstorms are much more threatening, nasty, and, above all, not just accompanied by gusts, but also driven by strong winds and an increasing sea. The thunderstorms can be very significant phenomena, and you can see this even by looking at this polar satellite image, giving an idea of how vast and impressive they can be. It's necessary to recognize the fair weather thunderstorms forming during daytime along the coast in the afternoon in generally anticyclonic conditions, with quite high temperatures. These thunderstorms restrict their effect locally, on the contrary of the frontal thunderstorms, which can form over the sea or mainland depending on the transit of the front, and are accompanied by much heavier marine weather conditions. A first sign, and a first element to realize, implies that the afternoon summer thunderstorms could be considered fair weather thunderstorms most of the time, whereas a storm forming offshore is almost always a sign of a significant change. If we observe a thunderstorm approaching and count the time interval between the lightning and the thunder, we can reasonably estimate at what distance the thunderstorm is from us and realize whether it is approaching. As the speed of light and therefore of the lightning is instantaneous, and the speed of sound is 330 meters per second, in case the interval between the lightning and the thunder is 10 seconds, the thunderstorm can be localized at a distance of about 3,300 meters. In fact, 3,300 meters divided by 10 seconds corresponds to about 1.5 or 2 miles. The waterspouts are feared by many, but our experience teaches us that they can be avoided when sailing. Although conditions are difficult, it is unlikely that this phenomenon can hit a vessel when sailing and endanger its safety. The risk of waterspouts is greater along the coastal areas reaching, for example, harbours in a bay with very strong and whirling winds. In this case, the vessels caught by surprise at anchor would find themselves, for example, in a difficult situation. Other times, the waterspouts can reach a port with such a force that they are capable of capsizing boats raised on a haulage. Summing up, a waterspout is an impressive phenomenon, but much more dangerous along the coast than at sea.